general relativity, step by step. What I've got in this rather fearsome looking set of equations here is the Einstein field equations in its usual form. And what I've got here is I've rewritten the Ricci tensor with two upstairs indices as a product of three metric tensors with the Riemann tensor having 1, 2, 3, 4 downstairs indices. And this thing here is the curvature scalar, the Kretschmann constant, which is multiplying the Riemann-Christoffel tensor by these two matrices here, and we have our metric tensor here, which is this one here. So all I've done is expand the definitions of those terms in the Einstein field equations, equals 8 pi g times the stress-energy tensor. Okay, and what I've got here is what I developed in the previous screencast, which is a first-order approximation for the Riemann-Christoffel tensor, again with 1, 2, 3, 4 downstairs indices. And of course, what I'm going to do is to substitute this expression here into this equation here, into this term here. But here's the clever bit. Well, it's one of many, many clever bits of this process. Because I'm only working to first order, it means that I can do something quite clever, and we'll see it's got far-reaching consequences. I'm going to replace the metric tensor G with the flat space Minkowski tensor G. No, I'm replacing it with a G. Eta, the flat space tensor, where of course eta equals minus 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Constant, as I've said many times. Okay, well, there's nothing for it. We've just got to jump in here. It's difficult, but we're just going to have to do it. I'm just going to substitute that into there. I'm going to take this factor of a half out before I forget, and that multiplies up here. So the right-hand side is going to be equal to 16 pi gt gamma sigma. That's the right-hand side, and I'm going to work out the left-hand side now. So copying from here, eta gamma beta, eta sigma mu, eta alpha mu. Acting on this term here, di beta, di mu, h alpha mu. Okay, now there's quite a lot going on here, but I'm going to make the observation, I'm going to change to a slightly nicer colour here, that these guys here are constant. Look, there they are. There's just ones and zeros and a minus one, I guess. And so they're constant. So they can move past, they commute past this differential operator here. And if I change colour again, let's take to this beautiful orange colour, then these guys here can go to the front. Or is that the back? Anyway, they can go to the left-hand side. Okay, well, I'm not actually going to rewrite it. I'm going to go back to black. And I'm just going to imagine that I've done that. And the idea is to raise all the indices that I possibly can. What I want to do is to have the expression with two upstairs indices, but on the h, two superscripts on h. Okay, so am I in black? Yes. So let's just have a look at this term. That's a gamma beta. So this term here, maybe I'll use red to join those two lines there. Oh, red. This term here is going to contract with that operator there to leave me with, if I can go back to black, a di gamma by definition. Now what am I going to do? I'm going to contract, I'll go back to red. Actually, I'll have too much red, but I'll live with that. This guy here is going to work with, no, I want to think of it in terms of indices. So that index there is summed, that's not very neat, is summed with that mu there. And this alpha here, said I was going to have too much red, that alpha there is going to sum with that one there. So what have I got left? I'd better go back to black. At this moment, I don't mind confessing, this is the 6th or 7th attempt at this particular screencast, and I've got it wrong every single time. There's a lot to get wrong here. Am I in black? Yes. Right. So I better tick stuff off that I've done. we have done this term here. I can cross that one out. Tick. I am going to have a mu downstairs and an h. That alpha has turned into a mu there. That nu, this nu here, sums with that sigma there. Is that right? Yeah, that looks right to me. Of course, it's symmetric here, so we don't need to worry about the order of those terms. Whew. Well, that's beautiful. And what I'm going to do in subsequent screencasts, how long has this one been? 5 minutes? I'm going to do the same process on all the other terms. So we've done one down, 7 to go. I'm going to stop there. Stop.